In this video, we're just going to talk about Newton's three laws of motion, which you probably did cover at GCSE Science, but it's worth just going over these before we enter into them during Unit 2. So the first law of motion just describes an object will continue in a state of rest or uniform motion in a straight line unless acted on by a resultant force. So technically, we can have our object just resting on a plane, and we call that in equilibrium, where all forces are balancing each other out, there's no movement. Or we can have this object moving at a constant speed of, say, 3 meters per second, and as long as no other external force acts on that object, it will continue moving at 3 meters per second, and that's obviously the other option that you can have. In Newton's second law, and probably his most famous one, this deals directly with the equation F equals ma. The technical explanation is the rate of change of momentum of a object is directly proportional to the resultant force applied and its direction of the resultant force. Basically, F equals ma means if you apply a force to an object, you're going to get an acceleration. So if you do something to an object that's in equilibrium or moving at constant speed, apply an external force, it will either start to decelerate or accelerate in proportion to the force in proportion to the mass and the acceleration. So technically, all we need to remember here is force will be measured in newtons, mass in kilograms, and acceleration in ms minus 2. I wouldn't worry too much about this second equation, which is obviously a variation of it. We'll talk about this more when we come to Unit 4. Newton's third law basically states when two objects interact, they exert equal and opposite forces on each other. This can be simply described as, say, for example, a mass resting on a tabletop. Obviously, if we say this mass was 4 kilograms in mass, it would apply a weight of 4g to the centre of the Earth. Remember, force is mass times acceleration, or weight is mass times acceleration, so mg. Now, obviously, if this object does not actually fall through the surface, or it's not pushed back into the air by the surface, then what must be happening is the surface must be applying an equal and opposite force outwards. We call this the reaction force. So for every force acting down, i.e. the 4g, there's a 4g force acting back.